Hello, this is just a bit of generic advice for your Criteria BC, your lab report write-ups. Here is the writing frame that I give you. I'm just going to talk briefly through the sections and the things that I normally see people make mistakes on. First one, title of lab, you are expected to give it a title, something very simple that summarises the sort of area that you are studying. The next bit, background research, this should fall into two sections. The first part you could look at is the simplest bit, which is identifying who might be interested in the outcome of your study. Think jobs, think sports, think interests. Who might be interested in knowing the outcome of this? Jobs is normally a really simple section to think about, and why might they be interested? The next bit is the research itself. You need to explain any scientific theories, formula, concepts that you're then going to refer to later when you do your prediction and your evaluation of hypothesis and stuff like that. If you've used any websites, they should be listed in the references. You don't have to, it's not graded on this, and there's no expectation for you to do it in a particular format, but it is good practice to acknowledge stuff when you use them. If you fail to do it, then that is plagiarism, and whilst it's not that you don't get a grade on your plagiarism, but it is a very serious offence if we plagiarise. It's an ethical thing. Then we come up with our question, and we get rid of this advice bit. You write down your independent variable, and you try to be specific. Try to give me some numbers and some sizes or parameters that are relevant, and then the same. You say, how does it affect the dependent variable? Again, with detail. Let's try and narrow it right down to the zone. If you're doing an experiment and you're changing temperatures, what are the ranges of temperatures? If you're dropping stuff and looking at free fall, what are the different heights we're dealing with? So that people reading it know, are we talking about dropping something from a helicopter or dropping something from a table? So they have a vague idea. Similar with the hypothesis, make this into a sentence. It should go if, independent variable, then, dependent variable, and replace these with what yours is. And then we're going to explain why. And this is going to link back to your background research where you explain any scientific concepts you need. Again, reference things if you need to, but this should be your own interpretation of how that concept fits into this experiment. Then we look at the variables, so you need to tell me your independent variable, the increments, this is the different sizes of something you'll do, the different heights you'll drop things from, the different temperatures, whatever it is that you're changing, what specific ones are you doing, and why have you selected them, and how are you going to actually get them? What are you going to do experimentally to achieve that? If you're dropping things from different heights, how are you going to know what height you're dropping it from? Are we talking about the bottom or the top of an object? All this sort of stuff. Where are we measuring it? How many repeats you will do, like will you do 3 or 5 or more? Typically an experiment in MYP is 3-ish. DP should be minimum 5. I think in MYP we should be aiming towards 5 as well, but time obviously is a factor to play in that. If you're dealing with people or things that are less predictable, we should be doing more repeats to make sure we are getting a reliable outcome. Dependent variable, what is your dependent variable and how are you going to measure it? Then we should talk about some control variables. I've suggested 5 boxes here. That doesn't mean you have to come up with 5. That doesn't mean you're limited to 5. What it is not is we don't say things like stop clock. The stop clock is not. If we used one stop clock one time and then use your phone to time it the next time, that does not change your experiment, and therefore it's not necessary to control it. Control variables are things that are going to affect the outcome of your experiment. If we're dropping something, what would change how it falls? You stood there with a different stop clock will not change how it falls. Materials, this is the equipment you're going to need, all of it listed in as much detail as possible. If you want paper, I want you to tell me what size paper you want, what grams per metre squared paper you're going to want. Does it need to be a specific colour? everything you need so that you're not disappointed when the wrong equipment arrives. Method is all the steps you did to obtain your results, all the things you do, how you do it, and how you make sure that your control variables are controlled. So that kind of level of detail should be in there. If you've got a chemical of a certain molar or percentage, state what percentage and why, and how you will achieve that. Safety is all the things that could go wrong and how you will stop them going wrong. The first box will tell me what could go wrong and what the problem would be, and then this one should be how you're going to stop that happening. Then we do our results, and you can have a data table like this with your raw data here and then your processed ones here. Range is like the difference between the smallest of your trials and the biggest of your trials, and this is something you then comment on in your evaluation, because you can talk about your results being reliable. If you've got a really small range, then your results are reliable. If you get a massive range and your numbers are all over the place, if you repeated it, you couldn't really predict what the next one would be. If you have a really small range, then you could feasibly predict what the next, if you did a fourth trial, you could predict what the fourth trial would be. And that means your results are reliable, and that's what we comment on here. But obviously, if it's a good thing, if it's a small range, we don't need to fill in the improvement box because it's small. Although sometimes, even a good thing, we can make it better. We should have our graph. We should be talking about independent on the x-axis and the dependent on the y with our units. We should have a title for it. Make it all look neat and smart. One of the most common mistakes is not doing a straight line of best fit or a trend line. That people often do dot to dots. That is incorrect. Don't do that. It should be a trend line. Other thing people do in the results table is they don't put the consistent number of decimal places. So they write things like 1 here and then 2.4 here. That's not consistent. That could be changed to 1.0 for consistency. Conclusion, tell me what your overall pattern is that you see in your graph. So as the independent increases, the dependent increases, is what I see here. Tell me data that agrees with it, and then maybe there's some examples of within trial number 1, maybe it went up to 3.0 and then went back down to 2.0. So we can talk about things that don't necessarily agree with it. Evaluation of hypothesis, tell me again your hypothesis and why you thought that, and then tell me about all of the data that agrees and disagrees. Giving me one is not good enough, so saying the graph supports it is not good enough on its own for a high grade. We need to talk about the graph, we need to talk about the averages, we need to talk about individual data points that agree with it and disagree with it. We're evaluating something, we're giving everything you can think of, and we're trying to link it to science. Evaluation of method is talking about all the things that you did in your method that was effective and all the things that weren't. Things like if you were measuring temperature, did you measure it using a thermometer? Can you see decimal points using a mercury or alcohol thermometer, or do you need a digital thermometer to make it better? These are the things that we're talking about here. And then extensions and improvements is kind of looking at further studies you could do. So if you're doing an experiment and you realize some things that are of interest, then you're making a suggestion, I would like to study, or a next study could be, let's say you're dropping things from different heights. A further study could be drop it from a different height. So if you did 1 meter, 2 meters and 3 meters, what happens at 10, 20, 100, 200, 1,000? Try those. What happens if we did the same experiment in a room that is a vacuum? Anything you can think of that would change your experiment, these are improvements and extensions. And then that should, if you follow all of this advice and complete everything fully, you should get a